Okay, alright, so today we're going to do something called a radian measure of an angle size. Now previously, with all the angles that you are measuring, we always use degree to do the measurement. The use of degree to measure the angle, angle size is based on astronomy, it's not based on mathematics. So in the later future lessons, when we start to do the differentiations and integrations, or the calculus of trigonometry, then we always use a radian to do it. Right, so what is radian measure? Alright, so say for example we've got a circle and we're looking at the size AOB, this angle here. Alright, with radian measure, the size of angle AOB is equal to the ratio of the length of arc AB. So length of arc AB, which is the distance here, divided by the radius of the circle, right? So divided by arc. So it's actually equals to arc of AB divided by the radius r. And that's the length of AOB. All right, so that's the angle of AOB, which is in radian measures. Now, how do we know some common radians? All right, so for example, if I have one revolution, like 360 degrees. So the first one, all right, the first case is we have a 360-degree angle, a revolution. Then if we want to find out this angle here, so the size of this angle is equal to, if we use the formula, the arc of AB. Now this time, the arc of AB is going to be this entire circumference of this circle. And the circumference of the circle, we can use the formula 2 pi r to calculate. That is the circumference of the circle. And if we divide this radius by r, we're going to get 2 pi. So now 360 degrees is equivalent to 2 pi in radian. Now please remember they're not equal to each other, all right? 2 pi is roughly equal to 6 point something. But 360 degrees is different to 6.28. So that's different. It's just equivalent. All right, 360 degrees is equivalent to 2 pi. All right. So what about a straight angle? If you think about a straight angle here, then angle AOB is going to be the length of AB this time. The length of AB, arc AB, which is semicircle. And that is actually 2 pi r over r. So that's equal to pi. So the 180 degrees is equivalent to pi radian. All right, now from here, we can actually derive some special, radian. So for example, 90 degrees is equivalent to half of the size here, which is pi on 2. And 45 degrees is going to be half of this angle one more time. That will be pi on 4. And we can have like 60 degrees. Those are all common angles, very special. And 60 degrees is like we divide 180 by 3, so that becomes pi on 3. And that's pi on 3 radian. And then the last one is 30 degrees is equal to pi on 6. Now this is something that you do need to memorize. The reason for that is just because of later when we're dealing with trigonometry, it's all in terms of radian. All right, now I'd like to show you how to convert any other angles, not the special angles, in degree to radian and vice versa. How do we convert this? So we'll start with degree to radian. All right, what do we do if we have just like 25 degrees or 40 degrees? What do we do, okay? The way to do it, the formula tells you that, all right, if you want to convert degree to radian, it's actually really simple. You times by pi over 180 degrees. That's what you have to do. You times any angle in degrees by pi over 180, and then you do get the answer. So for an example here, if I have 20 degrees and I want to convert that into radian, then all we have to do is do 20 times by pi over 180, and that gives you pi over 9 radian. It's just another measurement of angles, right? All right, so that's really easy. All right, another one is it could be something that's greater than 180, like 300 degrees. Now, if I want to convert that into radian, then it can be 300 times by pi over 180. All right, and then we can obviously do the simplification. That becomes 300 pi over 180. Cross this one out and divide everything by 3. That gives you 10 pi over 6. And we can further simplify this one to 5 pi over 3. That becomes the radian. All right, so by using this method here, you can actually work out any angles in degree. You can convert that into radian. Now, there's something that you do need to remember here, and this is where most people get a bit confused. If you look at all the radians of, all right, just right here, pi on 9, all right, 5 pi on 3, pi on 4, pi on 2, pi on 3, pi on 6, pi and 2 pi. It looks like, all right, this gives you some impression that radian is always in terms of pi, okay? It looks like it, right? It looks like everything's in terms of pi, because if you're using this formula here, yeah, everything looks like it's in terms of pi. Is that correct? Not really. We can have 1 radian. We can have like 2.5 radian, not in terms of pi. The reason they're all in terms of pi is because those angles right now are whole angles. They're whole numbers, like integers. So therefore, you can have, when you divide this number here, those numbers here, by 180 degrees, you're going to get a fraction, a nice fraction. All right, you don't always expect the radian of an angle is always in terms of pi, okay? It can be 1 radian. So how do we write 1 radian? Now, from now on, when it comes to a trigonometry question, or if you later want to write something in terms of degree or radian, you have to specify. So, for example, if you write sign 30 without writing that 30 degree, without that degree sign here, I am going to assume that 30 is 30 radian. Okay, so this is really important because it's really different, all right, when you do a sine 30 degrees or sine 30 radian. All right, it will give you a totally different answer. Totally different answer. So this time, start from now, if you don't write this little circle here, all right, to represent the angle is a degree, it is going to assume that it's radian. So make sure that you remember how to specify whether you want to write your angle is radian or degree. This is really important. All right, next, I'd like to show you how to convert from a radian to degree. All right, it's just the opposite. All right, previously you times by pi over 180. Now this time you divide by pi over 180. All right, so one is times, the other one is, divide. Now, if you don't want to write this division here, you can actually write something like times 180 over pi. That's something you can write. It's just the same thing. All right. So an example of that would be something like, I have pi over 5 radian, and I want to convert that into degree. So I will do pi over 5 times by 180, all right, over pi. Cross these 2 pi out, you're going to get 180 divided by 5, which is 36. And make sure you write down 36 degree. So that tells you that 36 degree is equivalent to pi on 5 radian. All right, what about this time now? 1 radian, like not degree, but 1, just 1, okay? 1 radian, how do we do it? Same thing. Doesn't matter if it's a radian is in terms of pi or not, you do the same thing. It'll be just 1 times by 180 over pi. Now, if you want to do it, you can use your calculator and try to work out what's 180 divided by pi, and that will be your angle in degree. All right, so let's try this. The angle in degree is 57.3 degrees and to 1 decimal places. All right, that's 57.3 degree. That's what I mentioned about previously. All right, you can have more. You can have like decimal numbers here. Which means the radian is going to be a number that's not in terms of pi. So if you start with the whole angle here, then you probably will get a radian that is in terms of pi, but otherwise you're going to get a radian that's not in terms of pi, which is okay, all right? That's how you do it, all right? This is how you convert from radian to degree and degree to radian. Now you need to get used to this, all right? Because this time, for the later question, when we're dealing with trigonometry, it is always going to be in terms of radian. Unless the question tells you this is in terms of degree by providing that degree symbol here, all right? Otherwise, it's always in terms of radian. All right, short lesson, but that's all I want to teach you. I'll see you next time. Thank you.